Good morning to everyone here. So our project is to investigate the features and the design of an automated teller machine system, which is ATMs, the machine that you've been using every single day to cash out or bank in your money into a bank account. So our group consists of 3 members here, Ami Fakihi bin Zamri, Muhammad Aiman Akil bin Bahrudin, and me myself, Muhammad Ihsan bin Azmi. So let's proceed with the question number 1.
Okay, thank you. This is the use case for the automated teller emission system, which is ATMS. The ATM, we have the users and we have the bank server for the system. The first one we have for the users, we have the user need to verify the user through PIN. If they can verify, they can also check balance, transfer cash, withdraw cash, and if they want to do this, the bank server will do the job because after they have to withdraw the cash, the bank server will print the receipt also. Okay, next question. Okay, this is the functional system requirement. So for the user verification, this the ATM shall accurately verify user identity using a card and PIN. For the transaction processing, the ATM system shall display current account balance. The ATM system shall dispense cash in specific denomination subject to daily limit. The ATM system shall accept deposit of check or cash envelope. The ATM system shall transfer the fund between account or to another account. The ATM system shall allow payment for utilities or other services. For output provision, the ATM system shall display transactions detail and confirmation on the screen. The ATM system shall print receipt for complete transaction. Basically, this functional system requirement is the trajectory of the use case above. And we have non-functional requirement. Scroll. So we have the availability and security. For the availability, the ATM system shall be available for user access 24/7. For the security, the ATM system shall secure communication channel. With encryption, the ATM system shall verify session timeout for inactivity. The ATM system shall verify error handling for suspicious activity. So thank you. Next person. Sorry, we have the activity diagram. So this is the activity diagram for verification user, balance share, and cash withdrawal. The first one is for the customer. The customer will start the session, and the customer will insert the card, and the ATM will request the PIN. If the customer enter the PIN correctly, uh, they need to they can process the thing. If the customer forgot the PIN, they need to start again. And that's all for the you can see all the trajectory for the activity diagram. Thank you. So next person.
For question number 3 is about detailed test plan. First is test items and features to be tested. There are 22 test cases for this testing. First is user interface, and second user verification. Third for transaction processing. Fourth is output provision. Next is the test traceability matrix. Each of the requirements earlier will be matched through all the test cases for the 22 test cases. For example, here for requirement 1, the requirement description is the ATM system shall accurately verify user identity using a card and PIN. Its test case is for test case 6, which is TC6. It is accurate user identification using card and PIN. And then we'll do the testing and state the status, pass or fail. For TC1, TC2, TC3, TC4, TC5, TC7, and TC14 does not include in the traceability matrix because it does not directly map to any requirements as it focuses on the user interaction aspects. For C, for approach of specific black box techniques, we use equivalence partitioning, boundary value analysis, error guessing, state transition testing, and use case testing. For equivalence partitioning, we design test cases to cover valid and invalid inputs for functions like pin entry, transaction amounts, and account numbers. For boundary value analysis, we test functionalities at the edge of expected values. For example, we test cache withdrawal with minimum and maximum allowed amounts. Third is the error guessing. Test cases will be designed to simulate potential errors users might make. Next is the state transition testing. We design test cases that cover different system states, such as login user, and inactive session and card error states. And lastly is use case testing. We analyze typical user workflows and design test cases that follow these use cases. This ensures the system behaves as expected throughout the entire user interaction process. And lastly is the plan, schedule, tasks, and activities. We do the testing for 6 weeks. On the first week, the task is review ATM requirements and functionalities. On second week, we design test cases based on blackboard techniques. On third week, we prepare testing environment. There are two environment, which is simulated ATM and actual ATM, which for simulated ATM, we install and configure the testing software, and for actual ATM, we obtain permission and use test account. On week 4, we execute test cases for functionalities, and we also report bugs with clear descriptions, expected behavior, and potential impact. On week 5, we analyze test results and identify root causes of defects, and also collaborate with developers to ensure bug fixes are implemented. And week 6, the last week, we perform regression testing to ensure no new regressions were introduced by bug fixes, and also finalize test documentation. That's for question number 3.
Okay, so we move to question number 4, which I will be presenting about equivalence partitioning test conditions and coverage, which I have to refer from question 2 in scenarios, and I also refer to question number 3 for the test cases. So in this case, we want to combine question 3 and number 2. So it will be test cases number 6 up to test case number 12. Okay, so we move to the table here. Okay, so we have 12 test cases here. There's description, what is the test cases about. So we have valid partitions, invalid partitions, and we also have test data for valid partitions and invalid partitions. So I give you example for number 6, user identification. So the valid partitions is which is you need to put the PIN number correctly. Invalid partitions, which is you put the PIN number incorrectly or the card is expired. So the data is the PIN is 1, 2, 3, 4, 5, 6, and or 7, 8, 9, 0, 12. Where on the invalid partitions, the number is incorrect. 1, 2, 3, 4, 5, 5, which is supposed to be 4, 5, 6. Or you put an empty pin, it will be an invalid card number. So I give you another example as well. Cash dispensing, which is test case number 10, where the valid partition is valid withdrawal or invalid withdrawal. So if you want to cash out, the bank can only cash out multiples of 10. So when you key in 20 ringgit, you will get 20 ringgit, double 10. But when it comes to invalid partitions, when you are entering a number which have decimal points, 15 ringgit point 50 cents, or minus or negative 20 ringgit, it will be an invalid partition, which will be rejected. So this is the equivalence partitions and coverage. So can we move to the next question? Okay, we move to the next question, which is decision table testing, which is showing the condition for multiple test conditions based on Ayman activity diagram on question number 2. There will be conditions here, which is insert card, enter pin, request action, valid pin, account status, withdrawal account, amount, balance, and action. So I have prepared 10 conditions here. So let's go through with a few of the conditions here. So we go for number 1. As you walk into the bank, you put your card inside the bank, the system will check whether your card is valid or not. And then you enter your PIN. After that, if the PIN is correct, you are able to withdraw your money. So let's say your account is still active, you want to withdraw 500 ringgit. And you enter the amount that you want to withdraw is 400 ringgit, which is sufficient funds. You have enough money to take out. So the system hence will give you 400 ringgit. That's for condition number 1. So for condition number 2, you have a card, but the problem here is that you want to withdraw more than the money which is inside your bank. You have 500 ringgit, but you want to withdraw 600 ringgit. So it will give a decline transaction stating that you have insufficient funds. So that's for number 2. Okay, we go for number 4. So for number 4 is that where you want to check your balance. So you put your card, you check the PIN, it's correct. So you have many lists that you want to do or action. You can withdraw or you can check your balance. So you press check balance. The account is active. So the withdraw amount is any amount is because it's not available yet because they want to check their status first. They want to check their balance. So the action is will be display balance. Okay, so we go to number 6. So number 6 here is that it's the same process, but you attempt putting your pin more than 3 times. Where when you put pin more than 3 times, the bank will block your card and itself it will not give back your card. So that's for number 6. So for number 7 is that you have a card, but you did not put any pin. So the process after that will not be counted. It will be none or it will be not available because you're still stuck at the pin process. Okay, so last one. So the last one is damaged card. So when you have a damaged card, you will not be able to use the bank. So the condition will stop until insert card. It will not go through enter pin until action. So basically, this is roughly of the test. Decision table testing to refer or based on Ayman's activity diagram. So that's all from me. We can proceed to the next question.
Next is the number 5. We designed a test case specification for all these functions. Test case ID, related feature, objective, covered test coverage items, input, expected output, special procedural requirements, and intercase dependency. Here are the test case table. Is for example here, the test case ID TC1. Related feature is user interface. Its objective is to verify card reader functionality. The covered test coverage items is user interface functionality. The inputs is valid ATM card, and the expected output is system prompts for PIN entry. There are non-special procedural requirements and not available for intercase dependency. For next example, here for TC6, its related feature is user verification. Its objective is to ensure accurate user identification. Its covered test coverage items is user authentication. Its input is valid ATM card and PIN. And the expected output is the system displays welcome message and account information. For special procedural requirements, there are none. And for intercase dependency is TC1, which is successful card read. For next example, we use TC13. It's for deposit. Its objective is to verify ability to deposit checks or cash. The input is valid check or cash envelope, and expected output is the system prompts for deposit confirmation and registers deposit amount. It may require specific feeder mechanism testing, and its dependency is TC6, which is successful user login. And that's all for the test cases. Number 5. Thank you.